our previous lesson, we were solving systems of linear equations algebraically. In 3.1, we solved them graphically. So in 3.3 here, we're going back to graphing. Although instead of having linear equations, now we're looking at linear inequalities. So these are the equations where you have to graph your linear line and then shade the region based on a point that you are testing. Okay? So we have two steps when graphing systems of inequalities. We first have to shade the region for each of our inequalities separately. Where these shaded regions intersect, well, that is the solution of our system. Okay, so we're going to do a lot of highlighting here. You can shade them lightly and then shade the region that they both intersect darker in your paper because you probably don't have highlighters and everything. That is just fine as well. I will kind of make expectations a little more clear on this during class, so don't stress if you don't fully understand the shading portion right away. So just like in the previous chapter, we need to go ahead and graph both of these separately. So we have x is greater than or equal to 5. So remember, when we have an x equals equation, that gives us a vertical line. So let's plot a point at x equals 5, which would be right there. And then go ahead and draw our vertical line. Okay, so before we go ahead and even graph our second line, let's go ahead and shade the region that would include the solutions for x is greater than or equal to 5. So obviously, you may be able to just read these inequalities and pick which side to shade, but let's pick a point. So what if we pick the point 5 or 6? Go back here. 6 and 0, which would be right on the outside here. Plug that into our equation. So that gives us 6 is greater than or equal to 5. This is a true statement. So that tells me that we are going to shade outside region of our graph here. Because anything greater than 5 is a solution to our first inequality. Okay? So let's do the same exact steps with our second inequality here. First, let's go ahead and solve for y. This gives us y is less than or equal to negative x plus 3. Let's go ahead and graph this linear equation. So our y-intercept is at 3, and our slope is negative 1. Plot a couple of points, and then draw in our lines. To give us something that looks like that. Okay? From here, let's test a point. Completely ignore what we've already done. Only focus on our second line here. A point outside of this line could be 0, 0. We always test 0, 0. So let's substitute that into our equation here. 0 is less than or equal to negative 0 plus 3. This simplifies to be 0 is less than or equal to 3. This is another true statement, so we're going to shade that side. Let's go ahead and grab a highlighter. Let's use that purple color. So we know that anything underneath this line is a solution to our inequality. Okay, so I didn't pick the best colors because where they overlap shaded in black, so that's kind of gross. But as you can tell, this region where they both overlap, which shaded in black for us, is the solution to our system of inequalities. That's where they both overlap. Okay? So let's answer the following questions. Is 5, -2 a solution to the system? So let's find our point. 5, -2. 2, 3, 4, 5, -2. Right here. Yes, that is a solution because it falls on the line, you know, to inside our shaded region here. So yes. Is 51 and -6 a solution? Well, this one obviously may be a little bit difficult to find. 51's down here, -96 is down here, but you can probably make a fair assumption that yes, this would also be a solution. If this was a test or quiz or something where we had to be extremely accurate, you would want to test this algebraically. So check. Check algebraically, okay, to make sure we are accurate. Okay, let's take a look at our second example here. We have 4x plus 5y is greater than -20, and 4x plus 5y is greater than 10. Okay, so let's solve both of these equations for y. So let's subtract 4x. That gives me 5y is greater than -4x minus 20. Go ahead and solve this for y. So let's divide 5. That gives me y equals -4 fifths x minus 4. Okay, so that's my first equation. So I can go ahead and graph this. One thing to remember is when we are graphing, there's no equal sign here. This has to be a greater than sign. When we are graphing inequalities with our greater than or less than signs without equal to, we do have to use a dashed line. So our y-intercept is at -4, and our slope is -4. 1, 2, 3, 4, run 5. There's another point. 2, 3, 4. 1, 2, 3, 4, 5. Just like that. So remember, we have to use our dashed lines when we are graphing our inequalities without the equal to sign. Okay? So that is our first equation there. So let's go ahead and check a solution. Let's check 0, 0. We might as well. Okay, so if we were to check 0, 0, let's substitute that into our equation here. 0 is greater than -4 fifths times 0 minus 4. Which gives me 0 is greater than -4. This right here, this is another true statement. We've been getting pretty lucky with our guesses so far. So let's go ahead and shade through region. Okay, so this might get a little bit messy with how much we are highlighting here, but that's okay. So let's go ahead and do the same with our second inequality here. I'll split our line here. So let's solve for y. Once again, for y is greater than -4x plus 10. Let's divide by 5. This gives us y is greater than -4 fifths x plus 2. Okay, so let's go ahead and graph this as well. Our y-intercept would be 2. Our slope, -4. Run 5. Up 4. Run 5. Okay, once again, we need to use a dashed line. Let's find our lines. It would give us something like this. You'll notice These are both parallel lines. Okay? Anyways, same system holds true here. Let's go ahead and test a point. Why don't we test 0, 0 as well? 0, 0 would fall below, which that would mean that our middle region is shaded. If this is untrue, then we have to shade above. So we have 0 is greater than negative 4 fifths times 0 plus 2. This tells me 0 is greater than 2. Okay, this right here, this is a false statement. 0 is not greater than 2. So we have to shade the side that does not include 0, 0, which would be our region. Let's see, I'm trying to test a color here. That would look better. That would be the region above. Oh, we might have to use our purple again just to see where it overlaps. So that's the region above our line here. Okay, so we have to use that gross black color again, but that's okay. So this region above our line is the solution to our inequalities, our system of inequalities. So that is how we graph our system. We have one more question here that tells us, what if you were to flip this first inequality symbol? What would be the solution to the inequality? Well, if you remember, we shaded this top equation with our green highlighter. So if we were to flip the inequality symbol, we would have to shade the region down here. Well, the thing that you would notice is we would have shading down in this lower region, and we'd have shading up here with that blank space in between, right? So these inequalities, if one of these symbols was to flip, they would never intersect or overlap each other. So you would just have no solutions, which is a very good possibility for a question like this. Okay? So I know this process can be a little bit tedious, and these questions do take quite a bit of time. So what we're going to do here is I'm going to have you guys try 3 and 4 on your own. Okay? For 3, you will have to graph an absolute value. Okay? For 4, you will have to graph 3 different linear inequalities. Okay? Both of these are things that you guys can totally handle and give it a try. Okay? So try these on your own. We will come to class, and the next day we will go over both of these examples together. Okay? Thanks for watching. Give these a try and come to class with questions that you have on both 3 and 4. Thanks for watching.